Hi scholars, so in the last video we learned that a percent, one way of thinking about it, is a part to whole ratio, and we said the percent is the particular one where it's the percent is out of 100, right? So for example, we had 2/5 would be how much out of 100, and we can cross multiply and solve for x if we wanted to, and find out that x in this case would be 40, which would mean that, right, 40% is the same as 2/5. Okay, these two, there's no new information here. These two things are identical, right? So let's take a look at a couple examples, sort of word problems where you're being asked to use this kind of a relationship, and we're going to use a calculator. So while this is very good, this is true, this proportion, it's not always necessary to set up a proportion in this way. We can actually use these shortcuts, okay? For example, in a class of 32 students, so that is the whole class, so in our part to whole comparison, that's going to be the whole. 6 students do not own a cell phone. So 6 students do not own a cell phone. What percentage of students own a cell phone? Well, so first off, we have to find out the number of students who do own a cell phone, and that can be calculated pretty easily. If out of those 32, there are only 6 who don't own it, we can find the difference there and find out that 26 students do own a cell phone. So 26 is the part that we're going to be calculating. So we want to find out 26 over 32. What percent is that? Okay, and we could set this up as x over 100 and cross multiply, solve for x, or we can just use our calculator. So let's do that real quick. If I do 26 divided by 32, I get 0.8125. So let's write that down. I get the answer is 0.8125. And that is the final answer. No, it's not. No, it's not. 0.8125 is the correct answer in decimal form, but we want to convert that into a percentage. So how do we convert a decimal to a percent? Right? Take that decimal place, move it over twice. Our final answer is the same thing, is 81.25%. This is the percentage of students who own a cell phone, right? 81.25%. 15% of Americans use ride-hailing apps such as Uber and Lyft. If the population of America is about 320 million, and so we can write that as 320 million, right? That would be 1,000, and then one more is a million. Then approximately, so that's an important word, approximately how many Americans use ride-hailing apps? So in this case, again, we can always set this up as a part to whole ratio, and that's going to equal the percent over 100, right? Or in this case, the 0.15 immediately, I'm just going to write it as 0.15. That's how I would convert 15%, right? This is the same as this, right? We've been doing this a lot. And the only real question is 320 million the part or the whole? Well, that's talking about the entire population of America, so that's going to be the whole, okay? Now, it is 320 million, but I'm just going to put in the number 320 here and understand that whatever the part, whatever number I end up with here, this value is in millions, right? So let's see how that looks. So if I have this equation, how would I solve for x? How would I solve for x, which is the parts, the number of people who use this ride-sharing app? And if it is easier for you to see, you could put this over 1 and then cross multiply, right? But notice that really when you're doing that, all you're doing is multiplying each side by 320, right? And that allows you to cancel these. All you have left on the left-hand side of the equation is x, and we're going to say that x is equal to 0.15 times 320. Well, what is that? I have no idea. Let's go to a calculator, right? That's okay. We're allowed to go to calculators. So we're going to go 0.15 times 320. We press enter. 48. All right. That's a nice number. So x is 48. Man, it's not 48 people, right? It's 48 million, okay? And you might wonder, well, what about if instead of putting 320, if I'd put at this number, right? What answer would I have gotten for x? And you could have done it, and you would have got 48 million, which is equivalent to 48 million, right? So either way is correct. 20% of the bananas sold by a store every day are rotten. If 16 bananas are rotten, then how many bananas are sold every day? So this is the same idea. It's the same setup. We still have a part-to-whole comparison. So we're still going to have a part-to-whole comparison. And it's going to equal our percent, right? Our percent over 100. And here we are given the parts that are rotten. So there are 16. Let's use a different color. So let's say the parts. There are 16 bananas that are rotten. Out of how many? Well, that's what the question's asking. They're saying how many bananas are sold every day. 16 out of, I don't know, how many? Is equal to 20, and I could write that as 20 over 100, or I can just immediately convert 20%, move the decimal place over twice, to 0.2, and this is the equation that now I need to solve. 16 out of how many is the equivalent to 0.2, or 20%, okay? And the question is, how do we solve this? Well, in this case, I have a denominator of x, and I really would like to get that out of the denominator position. It's really hard to solve an equation where you have a variable in a denominator, so I can multiply both sides of the equation by x, right? I could do it that way, or equivalently, you can write 0.2 as 0.2 over 1. You could have written it that way, and then you have a proportion and cross multiply. Whatever's easiest for you to do. In this case, if we go the first route where I'm multiplying both sides of the equation by x, these x's cancel, right? That's the value of doing that. And on this side, I have that 16. I'll just do it all in black now. I have that the 16 equals 0.2 times x. And we say, well, how the heck can I solve this problem? 0.2 times x. How do I get rid of the 0.2? It's just the same way you would if we had told you that 16 equals to 8x. You would have divided both sides by 8. Only in this case, we're going to divide both sides by 0.2. Okay? You can divide by a decimal. You can divide by a number less than 1. So let's do that in our calculator. We can clear that. And we have 16 divided by 0.2. And do we think the number is going to get larger, be larger or smaller? Let's see. Turns out that we have x equals 80. So this leads to x equals 80. Okay, so the number actually got larger. That's because when you divide by a number that is less than 1, your number is going to grow. When you divide by a number that's greater than 1, your number is going to shrink, okay? And so x equals 80, so how many bananas are sold every day? There are 80 bananas sold every day. Now, does this answer make sense? If 16 out of those 80 are rotten, right? We're saying 16 out of 80, is that equal to 20%? Does that equal 20%? That's a question. So if we wanted to check our work, right? We do all this nice math here, we get a number, we want to check our work. Does it make sense within the context of the question? And we can do it really easily. Let's type in on our calculator, right? We're using our calculator here. Let's type in 16 divided by 80. And what number do we want to get? Do we want to get 20? No, we want to get 0.2, right? 0.2 is the same as 20%, right? 20% or 0.2. These are the same thing, right? Because we can go back and forth from a percent to a decimal. So that's nice. So we have our final answer, x equals 80.